Hey guys, welcome back to Rocket Gyan, my fellow space tubers, and today I am really excited about the mission which is going today, and obviously it's going to space. But why is it so exciting? The reason being there are 3 rockets launching back to back, that too during a solar eclipse, and that too my favorite sounding rockets. How cool is that? So yes, hi Larry, hi Mark, Shri Sai Datta, welcome to the stream and Wildflower. This stream will be all about fun, rockets, space, and you should not miss this one because this is something which might happen once in a lifetime. And this kind of launches, although it happened previously, but now for probability of this to happen again is very slim. So we will talk about the mission, the rocket and everything. So just sit back and hopefully you shall be able to see what this mission is all about. So we are around T minus 30 minutes from the launch. Things are looking great. So hey Remeji, how are you? If you haven't liked the stream, do like it, and guys, please share it with your friends in your WhatsApp or Insta stories, because this is something to cheer about. This mission is something we should all cherish and see with actually live, right? So hey John, how are you? All right, so let's just jump into this mission. So what this mission is all about, everything we'll talk about it, but let's see what this rocket which is going to space is all about. So this is the Black Brant IX rocket. And this Black Brant IX rocket is powered by, you can see it's not a typical rocket which we are used to see, right? This is a different one. So basically this oh yeah, this is good. So this is powered by it. Oh, this is such a detailed picture, right? I also haven't zoomed in and see. So I'll talk about each and every components of this rocket. So yeah, don't worry about it. So first of all, this is a sounding rocket. So this rocket is going to go up to space and then come down. So it's not going to achieve an orbit. So sounding rocket is something which, you know, just goes up and then comes straight down. So there's that. Yeah. So basically that happens, and after that brahmos, no, it's not a brahmos. Okay, so yeah, so basically it's a two-stage rocket. It's a sounding rocket. It will go straight up and then come down. It will go today to a height of around approximately 420 kilometers, and then it will come straight down. So it's a two-stage rocket. First stage is the powered by Terrier Mark 70 booster, which is this one. Yeah, this is the Terrier Mark 70 booster. It has a burn time of around 6 seconds. It has these fins which are not active. Those are passive fins, but you can see they are in some sort of configuration which we call it as a cruciform configuration, where it's a diamond kind of shape, right? You can see that it is necessary because this diamond kind of shape ensures it is not moving around when it is in the launch phase. It's not destabilization, so spin stabilization and all comes into the picture, but yeah, we'll not go into that. So this is the first stage, Terrier Mark 70 booster. Then the second stage is this one, the Black Brant V second stage. It has a burn time of around 30 seconds or so, and it can take a payload of around 800 pounds to 350 kilometers and 300 pounds to 550 kilometers. So this black stage, this is the solid stage, and then this comes the payload bay. So here you can see all the umbilicals attached to all the payloads, right? Which will have basically these umbilicals are nothing but providing power, communications when it is in the ground stage, and all those things. So yeah, so this is one of the rockets, right? How cool is that? I'm saying this is one of the rockets, but yeah, all other three rockets are also similar. It will not have any as such things difference in it. What payload, I'll talk about the payload also, Sushant, don't worry. So yeah, it's happening in the eclipse. That's the main thing. And why are we going in the eclipse? I'll also talk about that. So moving on to the next one. Just a second. Yeah, so this is how it looks when all of the three rockets I should say, are on the pad. I mean, look at that, 3 rockets will be launching back to back, and we will be seeing all of them launching, back to back, and finally going up to space from 3 different pads, kind of, you can say that. So it will be launching from NASA Wallops Flight Facility, and yes, you can watch it once it will be live. So I'll tell you all those things about it, where to watch it from, and where to look at the sky if you live nearby. So that is the case. Watching Mexico totality. Yes. Okay. So yeah, these are the 3 rockets which will go to space today. And yes, this Black Brant rocket has its own family. So we have 1 2 3 4 5 6 7 8 9 10 11 12. So these are all the 12 launchers, you can say, which launches, which used to launch. Some are active, some are not active. Black Brant 9 and 12 are the most active ones. I'm not so sure about all those other things, but yeah, there is a full Black Brant family of these launchers. And so yeah, this is the case. They have been using this. I remember when the first launch from Australia which happened, which was the sounding rocket launch, and it was a Black Brant 9 launch, which is going to happen today. So that is the case. Now, okay, so where is it going? Why do we have this mission in solar eclipse? We will talk about that now. So first of all, it's going to around this ionosphere. It wants to study the ionosphere so that it is able to see how the solar eclipse changes the ionosphere. They wants to study, because what happens during a solar eclipse, you can simulate the day and the night kind of thing very free. You can simulate that kind of scenario in a very different manner. So it's not a natural one in which the ionosphere, the ions in the ionosphere will get time to settle down. It's a very fast process, right? So in 15 to 20 minutes window, the place where the solar eclipse is happening will be exposed to a sunlight, and then it will be a shadow, and then finally it will be again exposed. So they want to see how this exposure to shadow, moon shadow, and sun affects the ionosphere. So this is the main concept. So you can see it's around 350 kilometers. That's what they will be aiming for. Yeah, so this is the just a second. Yeah, so this is the team, and he's the head person. He's the person who is heading this mission, so you can say that. So these are the three payload bays. You can see all of them are similar in nature. They don't have much differences, but yes, so that is the case. And in 2017 also, when the solar eclipse happened, they launched 3 back-to-back launchers like this today, and they were able to get some of the data out of it. So that is the case. So this is the APEP line of launchers. So APEP just stands for, what does it stand for? Just a second. Atmospheric perturbations around the eclipse path. That's what the APEP stands for. And it will, so basically it will study the ionosphere, as I said. And during the solar eclipse, the sunlight vanishes and reappears over a small part of the landscape almost at once. So in a flash, ionospheric temperature and density drop, then rise again, sending waves of ripples through the ionosphere. So there is a temperature difference, temperature gradient, which is created. The ions gradient, the charge particles gradient, again it is created. So because of all that, it sends out a ripples in space. More it's kind of like, when you throw in a stone and a ripple spreads, kind of like that only. So you can think of like this. So how the behavior looks when the sun is going through the ionosphere, it's like, if you think of ionosphere as a pond with some gentle ripples on it, the eclipse is like a motorboat that suddenly rips through the water and creates the ripples along the way. So that is the case. And so it will launch 3 rockets, one before 45 minutes, one at the peak of the one before 45 minutes before the solar eclipse, one at the peak of the solar eclipse around 81% totality, and then after the 45 minutes of the solar eclipse, when it is gone. After that it will launch. So it will be around 350 kilometers will be the altitude. And so yeah, this is like kind of what it will be doing basically. So moving on to the next one. So once it is in the space, it will launch 4 soda bottle like payloads. You can see that it's like 2-liter payloads, 2-liter soda bottle payloads, you can say that, because that is the size of it. But it has its own function. It will study the magnetosphere, will study the charge particles and other various things on it. So you can see these are all the those things, three soda bottle kind of payloads which will be deployed. I'll talk about that also. So that is the case. And this is another the boom, right? Another boom which will be used for measuring things. So let me tell you what all things it will be doing. 3 of these will mention that those bottles which will be launched will measure the plasma density, neutral density, and magnetic field. The 4th will measure the plasma density and the ion temperature. So that is the case. It will be deployed at around 3 meters per second velocity. Springs will be used for the deployment of it. And so the instruments will basically detect the changes in they have the Langmuir probes, the electric field probes, and the magnetometer, ionization gauges, accelerometers, and all those things. So basically the payloads look like this. Anything else am I missing? No. Yeah, so the payloads are like this. So this is most probably the magnetometer. So yeah, you can see it from here, right? So this is how it will look like. So these payload bay will be opened from here, and all those 4 bottles will be ejected, and this is most probably a magnetometer boom, and we'll also having those Langmuir probes and other things as well. So this is how the configuration would look like once it is near to the deployment. So how does it so as I told you, right, I already told you that they have already launched in 2017, and they have measured things during that solar eclipse, and this is what happens. So you can see those contours, right? This is the pathway of the solar eclipse when it happened, and you can see how the ionosphere changes. So red means the high density of ions, the blue means the neutral density of ions, but you can see when the shadow goes over to the US, you can see how the ions are changing. The ions are basically getting aligned in that particular contour. So they have already studied it a bit, but they obviously need more data on it, so that's why they are launching 3 more. But you can see this is necessary because not only the what should I say, not only the ionosphere, we should be knowing about our ionosphere because satellites and all are there, communications and everything happens through that. So we should be knowing how each and everything affects our ionosphere, how solar eclipse affects our ionosphere. So so this is the mission we are talking about. So as I said, it was already launched in 2017, and this is the path of the 2024 solar eclipse. You can see that path of totality, 2024 path of totality, and it will be used for today's measurement. So they will be launching in the path of the solar eclipse, obviously, to take all the measurements and everything. So what this mission is all about, right? So okay, so what are the scientific objectives of this? So they want to know whether the eclipse shadow directly seed discernible irregularities in the mid-latitude ionosphere. What are the lengths and time scales? So what does this mean is whether the eclipse is able to seed some sort of irregularities in our ionosphere. If it is so, then we should be studying about it so that we can be better prepared for other eclipse when our traffic in the ionosphere, which means the satellites in the ionosphere, increases. We need to know about all these minute details. So other thing is, what are the impact of density, temperature and conductivity gradients in seeding small scale, tens of meters to kilometers, ionospheric irregularities in the presence of solar eclipse. Again, this is nothing but it says like what are the impacts on the temperature gradient, the density of the ions, what conductivity gradient, all those things in the context of a solar eclipse. So they want to measure all these parameters, how they changes when a solar eclipse happens. And then finally we have how now you can see how do the different layers of the ionosphere behave differently in response to the overall cooling effect of the thermosphere. So that we have various things, right? The troposphere, stratosphere, thermosphere, ionosphere, the various layers of our atmosphere. They want to study when you suddenly, not suddenly, but in a very fast interval, you take away the sunlight from our from our sun. because of the eclipse, then what actually happened, how the thermosphere behaves, because usually it's a very gradual process. After 12 hours or so, the gradually the sun sets down, and the ions have their own time for all those things to happen, right? They are able to in the thermosphere itself, they are the molecules, the things present in thermosphere will be able to release the heat or whatsoever is the behavior. They can do it at their own pace. But when this sudden effect happens, then how those things behaves, we want to study that. So again, this is all comes down to some sort of relevance on better understanding of our space, as well as having those applications here on Earth. So we might not be having a direct application right now here on Earth, but this study or this simulation or whatever it is, you can say, whatever you want to call it, will eventually open up new studies and new applications also. How, we just don't know, so we always have to be better prepared about all this. So yeah, the next thing is, so yeah, now let's talk about the mission profile. So this is the mission profile which we have. So it will be going to around, you can say, 346 kilometers, 340 to 400. That's how it is, the altitude they are aiming for. So it will obviously have an ignition at t plus 0 seconds at carrier burnout, the first stage burnout at 6.2 seconds only. So yes, a lot of thrust for the first stage. Then we have the Black Brant ignition at 16 seconds. The burnout will happen at 43.5 seconds. Then we have a D spin. So after the spin which is induced during the launch of this rocket, they have to have a D-spin mechanism. And how will they D-spin? Most probably they will D-spin by deploying those booms, right? So there is a thing called moment of inertia and angular momentum. So if you have studied that, angular momentum is conserved, and moment of inertia, and in terms of rotational moment of inertia, when if you let's say you have seen those experiments, right? When the dumbbells are near, you are spinning and you have dumbbells in your hand. When you expand your hands, the rate of spin is reduced. Some sort of thing, similar thing might, I am not sure, but that's what they did for the previous one also. So they will deploy those magnetic booms, right? Which these ones here, you can see they have a weight around in these booms at the end of this, so that when these are deployed, the conservation of angular momentum will come into picture and it will slow it down. So that's how they will be aiming to slow it down. A very unique, a very high school physics ka application it is there. So how cool is that? Okay. Yeah, so that will happen at 60 seconds. The payload separation is 63, and then the swarm deployment, which is the 4 2-liter soda bottles, you can say, will be deployed at 73 seconds, and then it will work for around 7 to 8 minutes, and then it will come down. So that's how it will, a whole mission profile will look like. Now let's see how the mission the science profile looks like. So what happens, the payload separation will happen at around 88 kilometers. The D spin will happen, you can see that from here. The sub payload deploy at 107 kilometers. Then the whole rocket will flip, and then the nose cone will deploy at around 180 kilometers. And this is the up leg science phase, in which those probes which have been deployed, which will take the readings, as well as the probes which are there with the rocket will be taking the reading. And then finally at 90 plus kilometer, ram realign target 90 kilometers. Then down leg sign starts at 325 kilometers to 270 kilometers. So there are two phases, up leg signs and down leg signs. 180 to 325 kilometers is up leg signs, and then it will again rotate and to this in this phenomena, in this configuration, and then the down leg sign starts. at around from apogee 325 kilometers to 70 kilometers. So this is how it will look like. 90 plus kilometer DG sound, 75 to 115 kilometer meteor radar winds, 0 to 30 kilometer low cost balloon winds. So these are all those what should I say, the space weather kind of a things which will affect the overall mission. So that's how it is. Now we have already talked about all these things. So we have the rocket. Yeah, I think we have already talked about this. So this is the mission patch, again a very cool one. You can see the solar eclipse and the payloads in everything in the mission patch itself. Cool little thing I wanted to show you. So there is that. And now the most important thing, where to see this rocket from. So this is the map, guys. So launch site is near the Wallops. So if you live near it there, so 0 to 10 seconds is the visibility where you can see the rocket. If you live near Washington, Philadelphia, you should be able to see it after 10 seconds, 10 to 30 seconds, and even till Pittsburgh you will be able to see after 30 to 42 seconds. So you can take a screenshot or something and have a look at from your location where this rocket can be seen. So let's say if you are staying in Philadelphia, so you have to look at around south, little bit of southwest direction, or you can look at the south direction only, because the rocket will go in this direction. So you can start looking at the south direction at around t plus 10 seconds, but I would say to go around and start looking for the rocket at t minus 2 minutes only, because there will be some lags in the this frame in my videos and live stream. So just start looking at it, and if you miss, don't worry, you have 3 chances to capture it this time. So just stay there, and hopefully you will be able to see it. So let me see if we have the live stream now. Yep, just a second. There you go, guys. T plus 6 minutes, T minus 6 minutes remaining. Every
TM M&O.
Go ahead.
Yes, sir. On the swarms, I can confirm the fixed TM has a lock on 1 through 3, no lock on 4, and readout has a lock on 1 through 4.
Copy that.
Yeah, I have you covered with the animations and all. So
RSO, ROA.
This is RSO, stand by.
let me check whether there has been updation in the timing or not.
PLC, check 422.
Two 40 p.m. EDT. No, we don't have an update in the timings, as in we are well within the window. So here you can see, guys, this will be the left hand side rocket will be the first one to launch.
So go ahead.
Provide final wind weighted settings.
Final settings are as follows: azimuth 100.4, elevation 79.2.
Azimuth 100.4, elevation 79.2.
Good readback.
LC, ROA.
Go for LC.
MRL launcher, final wind weighted settings are azimuth 100.4, elevation 79.2.
LC copies and work.
And as you can hear, we just passed on the final launcher settings, azimuth and elevation. Came from our range safety officer to our ROA, range operations, and then on to launch control, who will make the settings at the launcher you see on the screen out at the launch pad on Wallops Island. This, of course, goes through safety scrutiny review to make sure that we avoid any hazards and remain within the hazard area dictated by our range safety officer.
So we are T minus 4.
We are now at 4 minutes and counting.
Okay, T minus 4 minutes from the launch. Everything is
Copy that.
looking
Check
great.
425.
So T minus 3 minutes, 30 seconds remaining. Everything is looking great. So if you have just joining in, guys, so this is the first rocket which will be launching before like let's say 45 minutes from the solar eclipse, which will begin. So we are 2:40 p.m. Eastern time. That is the launch time, and around 3 minutes remaining. So this is a Black Brant IX rocket. It will carry and study the ionosphere for us. And okay, is this from my side? I don't think so. Okay, it's fine. Yeah, so it will
Any perturbations around the Eclipse Path or APEP mission? Much easier to say APEP. I'll say that from here forward. APEP launch here from the MRL launcher on Wallops Island Range. We will have 3 rocket launches today. MRL will be our first launcher, which is the closest to you, looking our left on the left of the screen. The ARC will be our second launcher, which is not on screen currently. And then our third launch will be from our 50K launcher, which is currently on the right of screen that we're seeing now. Again, the APEP mission here during the eclipse to study disturbances in the ionosphere with our PI, Dr. Aro Perjadia, here from Embry-Riddle. We also have other co-PIs in this mission that we'll talk about after this first launch. We are now at 2 minutes and counting. Mark.
PTM check 434.
PLC check 435. Actual launcher settings.
so
are
T
as
minus 2 minutes
1000
remaining, guys.
elevation
One of the
set
launches, one of the launchers is going to launch very soon. So if you are just joining in, let me tell you, they will try to study the ionosphere during the solar eclipse, before, during, and after the solar eclipse. So this is the first launcher which is going to launch right now under 2 minutes remaining. Hit the like button, give your best wishes, and if you are just joining in, let me tell you, there is a way to see it from your balconies also. So here you take a screenshot and everything so that you can see the launch.
Go. STM. Go. ACS. Go. PI.
Go.
SRPO.
Go.
Check 438, 439.
T minus 1 minute remaining,
PLC check 441. Go.
and we are go for the launch. How cool is that? Okay, guys, this is happening. T minus 40 seconds remaining. One of the rockets launching right now. Oh my god. And don't blink, guys. It will just
Arm verified.
go
Check
away
item
like that.
445.
So we are at T minus 20, 19, 18, 17, 16, 15. Okay.
ACS check 447. Go.
14, 13, 12, 11.
10, 9, 8, 7, 6, 5, 4, 3, 2, 1.
Ignition.
0.
And okay, something happened. All right.
And our first APEP rocket has left the rail. Let's
Radar's
listen in.
retracting.
Fixed TM
Mission
readout
squib.
locked.
Okay, it was off a bit.
Plus
All
20.
TM antennas tracking.
Okay, guys, you can see in the animations how it will look like. The second stage must be burning right now.
Plus 30.
Here's now a look inside our RCC. That's the range team,
Plus 40.
as well as sounding rockets. Our PI, Dr. Brajati, is also in the room. All now,
Now
observing
the
data
burnout.
on the
Burnout must have happened right now.
front of
Plus
them.
50.
So now the payload separation will happen.
As we have launched
Squib. 1
our
minute.
first rocket
Separation
of a
squib
3-rocket
and break wire.
salvo today.
There you go.
Wallops
The
Island.
payload separation confirmed.
APEP mission.
ACS 1.
Swarm
ACS
doors
on
squib.
target.
Swarms have been deployed.
Got all plunger switches and break wires. Aft skirt squib.
And it is a successful first launch, guys.
Good lock on all 4 swarm. All are transmitting at high power.
all locks, there have been strong locks in all the 4 swarms. So they are able to right now record all the measurements and everything. So yes, there was a 2 to 3 seconds delay at the launch, but yep, it done and dusted. The first launch is gone.
Looks like all 4 booms extended.
Booms are extended. The magnetosphere, right? Sorry, the magnetic booms, magnetometer. You can see the face of the guy. He's the person who is heading this mission. So he is looking happy. So that is great.
Looks like the 0-degree boom did not deploy.
Ah, okay. One of the booms did not deploy. I'm not so sure whether it will affect the whole mission like that. I'm not so sure, but they will be able to somehow, manipulate the data from other booms so that they will be able to get the proper data.
Okay, we've passed 2 minutes, 40 seconds in flight for our first launch from the MRL launcher here at Wallops Flight Facility in support of the APEP launches. So thanks for joining us. Good afternoon. Just some information, some background on the 3 rocket salvo we'll be doing here today. Each rocket will deploy, you'll hear some of the chatter on the range networks. Each rocket is planning to deploy sub-payloads about the size of a 2-liter bottle of soda. Each rocket essentially creates 5 suborbital profiles, providing 15 different data sets from just 3 rockets. So that's all the data we're going to get from 3 launches today here at Wallops. The atmospheric and ionospheric perturbations can happen at any time and place, but why we like the eclipse, or why scientists like the eclipse, not including myself in that group of folks, most science campaigns have a 2 to 3 week window. With eclipses, they know exactly when this dynamic is going to happen, allowing science teams to craft an easy and comprehensive experiment to study the basic physics that would take them weeks, as said before. Again, this is the APEP mission.
So this is LPM. Are we clear to go outside just to check for any gross hazards?
So we're listening now to the LPM request permission.
Yeah, you're clear.
Go out to the pad
Copy that.
from the test director. Just going to check around, make sure there's no hazards, obvious hazards around the pad, safe the pad, and then we'll get ready to move on to our next rocket from our ARC launcher, which will be not on camera yet. They'll swing cameras around for a good view of that launch. And that one is slated for a 15:20 p.m. here on the Eastern time for rocket number 2.
So
right now we're going to share a video, the Eclipse Explainer video. So enjoy.
All right. So guys, don't go anywhere. We have 3 launches. 1 is done. 2 are still there.
Site of a total solar eclipse. The last time this took place was back in August of 43. When you check out an eclipse map that depicts the path of totality, keep this in mind. While many maps will show a circle representing the moon's shadow, the true shape of the umbra is more like an irregular polygon with slightly curved edges. This is due to the fact that the moon isn't a smooth sphere. It has mountains, valleys, and craters on its surface, all of which affect the passing sunlight and shape of the resulting shadow. NASA's Lunar Reconnaissance Orbiter spacecraft, which has been orbiting the moon since 2009, has provided scientists with incredibly detailed photographs
That, right? How cool is that? That one of our,
Thanks, Jamie, for that video. Make me. I didn't have to say penumbral.
this was such a good video, to be honest.
Shadows there. That was very good. I enjoyed that video. Education. Welcome back. We are here at Wallops Flight Facility in support of the APEP mission from NASA Wallops Flight Facility in Virginia. During this mission, we're going to launch 3 identical sounding rockets. We've already launched 1. This is going to study how the sudden drop in sunlight affects our upper atmosphere. The mission, known as Atmospheric Perturbations around the Eclipse Path, or APEP, is led by our PI, Dr. Raro Berjadia. He's a professor of engineering physics at Embry-Riddle Aeronautical University in Daytona Beach, Florida, and his research team is no stranger to Wallops. They've had mission launch from this site as recently as August of 2022. That mission was named SPEED, also an acronym, Speed Demon, tested technology that will be used on today's mission. But not only the team is no stranger to launching at Wallops, the payload that's being launched today has already successfully flown on a Wallops rocket. The same set of experiments were launched during the annular eclipse on October 14th in 2023 from the White Sands Missile Range in New Mexico. APEP is designed to measure changes in the ionosphere during the solar eclipses using instruments such as Langmuir probes, electric field probes, magnetometers, ionization gauges, and accelerometers.
All righty, and you can see that
Simultaneous multi-point measurements will be achieved by ejecting 4
the pad, this one on the
instrumented deployables from each payload or swarm. Springs are used to deploy the ejectables at a velocity of 3 meters per second, and they will take data for about 7 to 8 minutes. This allows taking measurements in a larger volume of space. So in the T plus, or in the T plus count, you heard a lot of chatter going on about ejecting things from the vehicle.
Yeah, when you
That's what that was
if you
discussing.
can
Let's listen
approximate
in now
when
to
the
range.
next T0 is, I can put it out to our external partners.
Copy. Stand by.
And you heard the TD asking for our next targeted T0, which we have as 3:20 p.m. here local on the East Coast, 1840 Zulu or GMT. For those listening outside of the Eastern Seaboard, we now have our camera.
all right, so
zoomed
you
in
can
on our ARC launcher.
see that retractor arm getting relaxed now because that arm has done its job.
TD is SRPO.
Go for TD.
We're targeting the nominal T0 for the second one of 1520.
There you go. 1520 Eastern,
No DPM.
around T minus 28 minutes from the launch.
So as you just heard, we're sticking with the originally targeted 1520 or 3:20 p.m. Eastern Time T0 for the second rocket in the APEP mission. Let's listen in the range control.
You can see the people are there.
Let the B clock roll and then fire the next vehicle on the A clock if that's okay.
For me.
The people just did a they will be doing a check around the pad so that there is no as such irregularities or fire or some anomalies over there.
Thank you, sir. Check 453.
So this is just the mission control chatter. So yes, one of the rockets have launched. Now we will be waiting for the others to launch very soon. So yeah, there you have it. So first of all, right now what you just saw was the Black Brant IX rocket going up to the space. Now again the other rocket will be launching. So the three rockets will have identical payloads, identical configuration. They want more data sets, so they are launching at different intervals.
Nominally, check item 454.
Copy that.
And TM and SRPO, I'm going to go ahead and put the clock at T-minus 15 without objection.
SRPO concurs.
PM concurs. I just want to keep the B clock rolling for safety reasons.
Copy. Programmer, 8 o'clock at T-minus 15 minutes and holding, please.
Roger, 15 and holding.
And LPM, do you need to align cameras again?
That's affirmed. We'll send them out now.
All right. Got arc avoidance?
RC, ROA.
Not necessary. This is RC, go ahead.
It's not necessary. You don't need it? LPM TD, you don't need arc avoidance?
That's affirmed. We do not need RF avoidance.
Copy.
And as you can see, we're taking a peek back into the RCC now, Range Control Center. As we've reset the clock to 15 minutes and holding, so they'll pick that up when we get closer to the terminal count for our second rocket launch today from Wallops Flight Facility, targeting a 3:20 local departure from the rail. We're about, let's call it 27 minutes away from our second launch. Just an overview of the rockets being used today. The vehicles for this scientific endeavor are Black Brant IXs, which are specifically designed for high altitude research. These rockets will soar to altitudes of up to 350 kilometers or 270 miles each, standing at an impressive 53 feet.
If it is 8 minutes
now
ahead,
for a science update.
Wildflower, you might have witnessed it, right? The launches. So guys, if you live nearby and you see this launches from wherever you are, just take a video and post it on the Twitter and we'll see it afterwards.
Set us up for a 1920 T0.
Roger, can do.
So what just happened? So we had one of the rockets lift off and have done its job, although there was one of the magnetic boom, which did not deploy. So there are multiple magnetic booms, let's say, which were...
As you can see there at the bottom of the screen, our PI, Dr. Burjadia, conferring with his science team. We're waiting now for a science update. Closely listening to the range feed to see if we have satisfaction on deployment of these sub payloads from the first rocket that launched from Wallops just 24 minutes ago. Let's listen in.
All right. So yeah, so at around 35 minutes from the first launch was...
1, 2, 3, 4, 5.
Now the second rocket will be launched during the peak solar eclipse, peak time of solar eclipse. So that will be around at 15:20. So they want to see before 35 minutes or 40 minutes at the peak and after 40 minutes. So this is how they mostly want to see how this rockets and how the ionosphere will behave accordingly. So as I said, they will have various instruments in there. The magnetometer, the temperature के लिए we have the temperature sensor, as well as
For our PI and some science updates, back to the rockets. The Black Brant IXs are a two-stage rocket, which means they have two separate
okay.
engines that fire in sequence to reach higher altitudes. That first stage is powered by a Terrier motor and will thrust the rocket, while the second stage uses a Black Brant motor. Both motors are powered by solid fuel, which will burn quickly, meaning this will be a very fast rocket. So as you saw from our first launch today, if you look away, you're going to miss it coming off the rail. Make sure we pay attention. It doesn't climb much like the Antares rockets that launch here to resupply the ISS. The sounding rockets are typically used to gather information about a specific phenomena or to test new technologies or instruments in a space-like environment. As we said earlier, we're getting right to the edge of space in the ionosphere today with these rockets, and they are fast off the rail. Check back in with the range feed.
Yep, that is the case. So yeah, as I was saying, it has the Langmuir probes, the electric field probes, magnetometer, ionization gauges, accelerometers, temperature sensor. All those things are there, and they will deploy 4 sub payloads, 4 2-liter soda kind of bottles, which will 3 of these will measure the plasma density, neutral density, and magnetic field, and the 4th will measure the plasma density and ion temperature. So
continuing more information about these sounding rockets, as we said, we get right to the edge of space, a space-like environment with a sounding rocket. They're not designed to reach orbit or stay in space for an extended period of time. They're designed to reach suborbital altitudes, typically between 50 and 1,500 kilometers above the Earth's surface before returning to the ground. Today's rockets are expected to reach a maximum altitude of 340 kilometers. These rockets are provided and built and integrated with the payloads on board as part of NASA's Sounding Rockets program, coordinated by the Sounding Rockets Program Office, or SRPO, located right here, NASA's Goddard Space Flight Center's Wallops Flight Facility. The Sounding Rocket Program Office plays a crucial role in providing suborbital launch vehicles, payload development, and field operations support for NASA and other government agencies across the globe, not just here at Wallops. They work hand in hand with the Sounding Rocket user community, offering launch opportunities that spanned a wide range of science applications.
there you go. We have the visuals on
Partnership
the
with SRPO
Black Brant IX rocket, the second one, which is going to launch. So Brian, if you have witnessed the launch from your home or wherever you were, please share it with us on Twitter, and we will see it after the launch. So you can do that by tagging me on Twitter @RocketGyan. The links are in the description. You can check that out. So anyone who is able to witness and record the video, if possible, please do that. Please share with us those videos. We will see it on the live stream itself and see how cool it looked from other perspectives as well.
That stimulates innovation, technology, maturation, and rapid responses to scientific events. And it looks like our camera is back on our next launcher, right? Yeah, we're ready for our next launcher, which will be the ARC. And we're still targeting that 1920 Zulu or GMT time, which will be a 3:20 local here on the East Coast for our second rocket in the APEP launch campaign, a 3-rocket salvo launching today from NASA's Wallops Flight Facility.
Go ahead.
All right, so we looked at the main payload data so far. It looks like all the booms did deploy.
Okay.
And the data does look pretty good. There are some squibbles on the accelerometer on the main payload that we seem to be seeing. We'll have to look more into that as to what that sporadic squibbles on the accelerometer are. We are still looking at the data of the ejectables, but it looks like all of them came out. And at first look, the coning looked smaller, which is very good. Yeah, and you know, as such, all the main payload instruments work great. Signals looked better than what we had seen during Vismer. So all that's good, and I'll keep you posted as we analyze the sub-payload data more. Over.
There you go. There you go, guys. We have a confirmation of all the booms deployment. Although there was some sort of issues some sort of anomaly in the accelerometer data. They will find out what was that. But other than that, everything was fine.
Dr. Arun Brajadia and his science update, it all sounds optimistic. Good data set coming in from our first launch of 3 here at Wallops Flight Facility. We've had some questions come online we wanted to address. Can I see the rocket contrails with my Eclipse glasses on? So no, you won't be able to see the rocket's contrail in the sky with your Eclipse glasses on. As long as you aren't looking directly at the sun, you can remove your glasses and look at the rocket and the rocket contrail. Again, do not look directly in the sun. This day or any day, but especially today, right? We don't look directly in the sun. I had to tell my mother that today via text. She asked me, if I wear my glasses, can I look at the sun? And I said, did you get Eclipse glasses? She goes, no, my prescription glasses. No, Mom, please don't wear those. Wear Eclipse glasses. We now have a video we're going to share with you on how to safely observe a solar eclipse.
To be honest, I haven't watched it. There have been couple of solar eclipses in my life till now, but I haven't watched any of them. But I will for sure from now onwards. But that pinhole camera one, I did not know that. I knew we can see the pinhole, see the sun using the pinhole camera, but even the tree leaves can or even anything. Obviously, now it makes sense. Anything which have certain small holes in it will be able to project that image. So yeah, awesome.
Do not remove your glasses looking directly into the sun, but away from them, you can try to catch the rockets and their contrails in flight. On camera now is our next launcher, the ARC from Wallops Flight Facility. We have launched one. Welcome back. We've launched one of 3 rockets as part of a 3-rocket salvo today from Wallops Flight Facility. We just passed 13 minutes, 13 minutes and counting for our second rocket launch as part of the APEP mission, or Atmospheric Perturbations around the Eclipse Path. Today, of course, many people across the United States here in North America, from Texas to Maine, will be treated to a stunning astronomical, and many people outside the path will see a partial eclipse. We here in the Virginia Wallops region are going to get about an 81% totality around peak totality time, which is 1530-ish, 330? 322 will be the most we'll see at 81% here in the Wallops region. This mission is led by Dr. Arob Barjadia from Embry-Riddle Aeronautical University, and they're aiming to study how the sudden reduction in sunlight during the eclipse affects our upper atmosphere or ionosphere.
Yep.
We just passed 12 minutes and counting for our second launch in the APEP mission. You can see the ARC launcher here. We've done station checks are complete. We're awaiting final launcher settings that we'll get. The ROA will request from the RSO, and after the RSO safety analysis, they will pass on the final settings. ROA will then pass those to LC. You'll hear as an acronym for launch control out at the pad, and they will adjust the rail with the vehicle on board, and we will be set to go for the second launch in our 3-rocket salvo as part of the APEP mission from Wallops Flight Facility today during the total solar eclipse.
Yeah, you are right, Wildflower. I will, for sure. Kind of, yes, you are right about it. Almost they have appears. So also, we have this thing, the superstitions or whatever you call it, that after a solar eclipse, there is some sort of natural calamity that happens, which I have experienced 2-3 times. So after solar eclipse, some sort of earthquake, some sort of something happens. I'm not so sure whether you believe in all those things or not. I certainly do not believe in it, but the data set suggests something happens. I don't know why, but yeah, there is that. So coming back to the rockets, we are around T minus 10 minutes 30 seconds from the launch. This is the second rocket which is going to be launched from here.
5, 4, 3, 2, 1. Mark. 10 minutes and counting.
Okay, 10 minutes and counting.
ACS check 473, 474.
Okay.
The RSO. This is PM on channel 1.
All right. So yeah, this is the second one which is going to launch. Again, this will be identical to the first one, and it will also deploy 4 sets. So this second one is the major one because this will be launched during the peak time of the solar eclipse. So the peak happens at around 322 over there, and it is launched at around 320. So you can expect they want to see the data set at the time of solar eclipse. Once that is done, after again 40 minutes, this third and the final one will be launched. So if you are just joining in and if you want to view it from your location itself, you can do so by following this viewing map. Here you can see various locations from where you can see it. Green area is where you can see it at around T plus instantaneously. Blue area at T plus 10 seconds. Pink areas at T plus 30 seconds. And as he said, you can't view this launch using your solar eclipse glasses. So remove it, and then you will be able to see it. So if you live around, let's say, Philadelphia, you should be looking at the south direction.
We just heard the PI has requested a hold. It's T minus 3 minutes. We're passing 8 minutes now and counting. Once we get to 3 minutes, we're going to hold no longer than 5 minutes. Our assumption is the PI is waiting on something he wants to see in the science realm. So we'll wait. That would put us to 322, and then plus the 3 we're holding would be a new T0 around 325 local here, Eastern time. Or earlier, right? They could pick it up. So we've got the live feed on. We will hear 5 minutes would have been the max. So max T0, the latest would be 325. It could be earlier. But we're all listening in with wanting ears as we approach totality here at 322 local in the Wallops, Virginia area. And we will hold at T minus 3 minutes. We are coming up on 7 minutes now and counting. And we'll hold for no longer than 5 minutes. Let's listen back to range control. There'll be a lot of chatter here now as we are in the terminal count, and all folks are providing inputs.
Okay. So there will be a hold at around T minus 3 minutes. Mostly, this is okay, good lock on swarms. That is good. Okay. So there the hold might be because of some sort of scientific data. The first launch which has happened, they must be confirming some.
Readout has a lock on all 4 swarms. Fixed TM has a lock on 1 through 3 swarms.
Okay.
check 486, good swarm data.
All right. Swarms are nothing but the deployed payload. So that is that. So he's checking whether the first launch which has happened is giving us the proper scientific data. So if it is giving us that data, then obviously you don't need to do anything else. But if it is not, then you need to somehow, alter your scientific instrument so that it suggests, so that you can, measure all the things which you want to measure properly. So at around T minus 3 minutes, they will be holding. But this is the second launch which is going to happen right now. Second of the 3 launches. One launch has happened. This is the Black Brant IX rocket. And you have to view this instantaneously, otherwise it will just go away. So right now they are just adjusting the the arm, so that also, guys, in this rocket you see that it is slightly.
We got our final wind weighted settings for our launcher from the RSO to the ROA. She will pass that on to the launch control out on the island, and they will set the launcher. We're passing T minus 5 minutes now, expecting a hold around 3 minutes. Just some information on the payload, as we talked about earlier. To capture a wide variety of data, these rockets are using technology that was developed and proven right here at NASA's Wallops Flight Facility. The swarm communications technology will release 4 sub-payloads that are carrying scientific instruments that will measure changes in electric and magnetic fields, density, and of course temperature. The swarm canisters act like additional rockets with their own telemetry and scientific instruments, and each rocket will carry 4 swarm canisters, which you can picture as a similar size and shape as a metal coffee thermos or a 2-liter bottle of soda. By ejecting multiple sub-payloads away from the main payload, the science team can collect additional valuable data. Each canister streams its unique telemetry and science data using onboard radios through the host rocket's communications system to the ground. Each rocket is carrying an identical set of 4 sub-payloads in the form of swarm capsules. 3 of the swarm capsules contain instruments built by a team from Embry-Riddle, and the 4th swarm capsule was built by researchers from Dartmouth College up in New Hampshire. SWARM is not an acronym. One of the challenges when designing a rocket payload is making sure it's properly protected during launch. When rockets experience extreme heat, pressure, and vibrations during the launch, so payloads must be designed to withstand these conditions and the rigor they are about to be put through. The payload skin that contains the scientific instruments for this rocket was designed, built, and tested by the Sounding Rockets Program Office right here at NASA's Wallops Flight Facility in Virginia. We are at 3 minutes, 35 seconds and counting, expecting a hold at 3 minutes, which would be no longer than 5 minutes. So our latest T0 would be 3:25 local, 19:25 GMT or Zulu time. We're coming up now on 3 minutes, 15 seconds, and we'll expect the hold. Let's listen into range audio.
So hold will happen anytime now. So we'll get to see. So the hold time is around 5 minutes only. So they
3
can,
minutes and holding.
and we have a hold. All right.
PI, this is SRPO.
Go ahead, SRPO.
Let us know when you want to pick up the count.
Sounds like a plan.
So
They-
it's best if we don't just try to pick it up right away. If we can announce a time that says this is the time we're going to start if we can.
All right. So they don't have much time to, hold this launch though. Only 5 minutes. So we'll have to see whether what is the thing they.
Current plan still is to pick up the count at 3:22, which would be the 5-minute hold from 17 to 20. That's the current plan.
Okay. At 3:22, they will be mostly be picking up the count, which means 3:25 is the expected launch time. So
TD, the planned new T0 is 15:25. Do you copy?
15:25.
Programmer copies as well, TD.
RSO, do you copy?
So as we just heard, SRPO polled the PI, who is our principal investigator, that's Dr. Brajadia, and he wishes to go to the end of the window, 5 minutes as the maximum hold they had indicated earlier. So we will go to that, putting our new T0 at 3:25 p.m. local and 19:25 GMT or Zulu time. I want to take this chance to talk about some of the teams that are involved in this launch salvo here from Wallops. Instruments on board the rocket were built by students and faculty members from Embry-Riddle, Dartmouth College in New Hampshire as well. A host of ground-based observations are going on throughout the nation today, and they're also going to support this mission. Co-investigators from the Massachusetts Institute of Technologies, Haystack Observatory in Westford, Massachusetts, will run their radar to measure ionospheric perturbations farther away from the eclipse path. And as well, a team of students from Embry-Riddle down in Florida will deploy high-altitude balloons reaching 100,000 feet every 20 minutes to measure weather changes as the eclipse passes by. All of these measurements will aid ionosphere modeling efforts led by scientists at the University of Colorado Boulder and Embry-Riddle. Those are the teams involved in the science portion here. Of course, we spoke about our SRPO, our Sounding Rockets Program Office here at Wallops. We also have Wallops range personnel involved, from project managers to test directors, launch pad managers, OCOM team, all the folks involved. Range safety, we have range safety officers. We have surveillance of hazard areas, a whole department within the range surveils offshore and in the general vicinity. To make sure that we keep the public, aviation, and our mariners safe from anything we're doing with regards to the launch.
all right.
Again, our cameras are fixed back on our next launcher, the ARC launcher, which is a rail launcher. We do have our final settings. We're still at 3 minutes and holding, and about, call it 5 minutes from T0 once we pick up the count. 15:25 is confirmed for our next T0. So let's listen in at range control.
All righty. So yes, so around T-4 minutes from the launch, range and the weather is supporting right now. There are certain people which are there nearby the rocket. You can see, right? People are there, but that is away from their safety zone. So don't worry about it. People will go inside most probably too. So or maybe they will just stay there. We have to wait and see. So yes, this is the second rocket, and as I was talking, this you must be seeing this rocket is is not straight. It's slightly bent. Why is it so? This is so because this is a sounding rocket powered by a solid rocket booster, which does not have a gimbal. So because of that, it is unable to change the direction. And
ahead of us. Looks like we got individuals that are on the hook that shouldn't be. RSO is looking at it to determine whether we're green or red at this time.
Oh my God. Wayward ships. No, we can't miss this, man. Oh,
3 minutes.
you're going with the countdown, but bro, why can't you just stay out of the zone? Why? You have to be there. This launch cannot be, you can't just reschedule this launch. It cannot be rescheduled. I was hoping we are able to launch this at the time of the launch, which is around T minus 2 minutes and 30 seconds remaining.
Hey, Jordan, can you zoom in? We can see how many people are in there.
Zoom in on which camera?
FLIR.
Stand by.
Go ahead.
This is SRPO. Are you guys picking up?
Yep.
PLC check 491.
So we need to know whether you're going to hold us or not.
I think we're okay, TD. I'm just we're given a based on number of people we see, getting the sub C value and making sure we're below our fixed values.
Copy.
Great. We are okay.
492.
We are okay with
493.
Okay, guys, T minus 2 minutes.
M&O DPM.
M&O.
Report TM lock and verify no change in TM signal strength.
All right. T minus 2 minutes from the launch. T minus 1 minute 30 seconds from the launch. Everything is looking great. We don't have any wayward ships as of now. Range is green. And the weather is holding it. So this is the second of the 3 launches, guys. Go out and look out for this launch. If you live nearby, this is the viewing map. So please get some videos and tag us.
100.9, elevation 79.3.
Okay, guys, it's happening. T minus 60 seconds from the launch. Everything is looking nominal. This is going to launch 4 sub payloads and measure the ionospheric interactions at the totality of the solar eclipse.
ACS check 502.
Experiment, you go.
Experiment go.
PLC.
PLC go.
PTM.
Go.
STM. Go. ACS.
Go.
PI.
Go, go, go.
SRPO.
Yay.
Go.
Check 503, 504.
30.
Match 30. 30 seconds remaining, guys.
Check item
Don't
5.
miss it. Don't blink your eyes now. Else you will miss it. T minus 20, 19, 18, 17, 16, 15, 14, 13, 12, 11, 10, 9, 8, 7, 6, 4, 3, 2, 1. Ignition.
Radar.
Ignition and lift off. There you go.
Ignition squib, motor pressure.
Whoa, this one was
Success,
good.
and our second vehicle has left the rail of the ARC launcher here, live from Wallops Flight Facility in Virginia. As part of the APEP launches, a 3-rocket salvo that NASA Wallops Flight Facility is launching today in conjunction with Dr. Aurora Berjadia from the Embry-Riddle Aeronautical University in Florida. APEP, of course, is an acronym. Atmospheric Perturbations around the
And we
Eclipse
have a
Path. We're
burnout.
launching 3 rockets today, 4 sub-payloads on each, for a total of 12.
We have a
different
burnout
data
now.
sets.
The next thing is the payload separation, which will happen. So you can see in the animations how it will look like, guys. I hope you like it. If you did, please give it a thumbs up. And we have a payload separation from the second stage. There you go. Ejection of all the swarms are done.
Units all are transmitting at high power.
All are transmitting.
On the booster.
There you go, guys. Swarms have been ejected. Everything is looking good, and they are reading all the data which is there from the swarms. So yes, second mission successful. We need to see whether the booms have any issues or not. In the previous launch,
Line and complete.
the booms, it felt like the booms did not deploy, but after the data was they got the proper data, they were like, okay, the booms have been deployed, but there was some certain anomaly in the accelerometer. So let's hope that is not the case in this one, this launch. So yeah. So now the science phase actually starts. So they have an up leg science phase and a down leg science phase. So up leg starts at around 180 kilometers to 350 kilometers, where the magnetometer side is facing upwards. After that, the down leg science phase starts, where the magnetometer is facing downwards. Those magnetic booms, or whatever you want to say. And that is the down leg phase for around 325 kilometers to the 70 kilometers. So that is the phase. So, and the swarms which have been deployed, those 4 2-liter soda bottles, whatever you want to say, those works for 7 to 8 minutes, collecting data on the ionosphere, the magnetic field, plasma density, neutral density, temperatures, and all those things. So yeah, so this mission, 2 of 3 is done and dusted. Now we are just left with the last mission, which will be launched around 40 minutes from now. So we'll see. Yep, it's already in space. It's very, very, very fast. So those solid rocket boosters are, you can say that those power the ICBMs also. Kind of, you can say that. But yeah, it's in space. It's in space, but it's not in orbit. So it will just go up and then come down. So it will not stay in the space, because for staying in the space, you need to go up and then go sideways really, really fast. Otherwise, you will just fall down, which is going to happen for this one.
Potentiometers show booms deployed.
Booms
as far
are
as micro switches, I got all except for the 0-degree micro switch.
all booms deployed successfully. There you go, guys. So T plus 4 minutes, 14 seconds, and we have everything running nominally.
PD, RSO, this LPM, can we check outside for gross hazards?
So you good with that?
RSO's good with that. We're at plus 2 minutes.
We're good.
All right, that was fun. 2 launches we have seen on the first time I have seen 2 launches back to back.
As we
I will
approach
have to see
5
the
minutes
third
in flight
also.
for our second vehicle launch here from Wallops Flight Facility today as part of the APEP mission. We can go. I wanted to discuss one more time about the mission that is at hand here. We have 1 launch left of 3, known as the Atmospheric Perturbations around the Eclipse Path, or APEP, led by our PI, Dr. Aro Berjadia, a professor of engineering physics at Embry-Riddle Aeronautical University in Daytona Beach, Florida. This research team is no stranger to Wallops and had a mission launch from this site as recently as August 2022. That mission, named Speed Demon, tested technology that will be used on today's mission. Not only is the team no stranger to launching at Wallops, but the payload that's being launched today has already successfully flown from right here on a Wallops rocket, courtesy of our Sounding Rocket Program Office. The same set of experiments were launched during the annular eclipse on October 14th, 2023 from the White Sands Missile Range in New Mexico.
Glad you liked.
We're now approaching 6 minutes
Denise.
in flight, and we'll listen into range control for an update on the next launch, which is slated for a T0 of 4:05 p.m. Eastern Time or 16:05.
4:05 Eastern, so that will be a long wait, I guess.
ACS-3 aligned and complete.
SRPO TD, do you have an estimated next T0?
Stand by. TD SRPO.
Go for TD.
We're currently targeting a new nominal T0 of 1615, but the PIs continue to assess.
Copy.
1615. Okay.
When do you want to make that decision, SRPO? Do you want to push through the same way we did last time or hold earlier? TD's PM, we're going to conduct the same plan we did last time, shifting the 0, 15 with a hold at T-3 to get there. Do you concur?
Concurs.
RSO, do you copy?
RSO copies 1615.
Okay. Cool. So we have we will be having again the hold at 1615, but this will be the last launch which is going to happen. Hope you liked the animations which are going so that you can see what is happening with the launch. So if you did, please give it a thumbs up and subscribe if you haven't already, guys. And if you want to support me, you can become a Patreon or a member of this channel so that I can keep on doing all these various launch live streams and other related videos. So do check it out. And yeah, so we have super, you missed it, no worries, you have the third and the last chance now. Praise MNSA, right? Last chance to see. Okay, talking about the last chance to see, this is the viewing map, guys. You can follow this viewing map to see where to look at in the sky and when to look at. So accordingly you can see, right, from the Washington, if you're living near Washington, you can see you have to look in the southeast direction, and at around T+10 seconds you will be able to see the launcher. So that is the case. Things are looking good. They are getting the data, and hopefully, so the person who is sitting in the center is the main guy who is heading this project. He has already launched 3 of these launchers at the 2017 solar eclipse. So they already have the data, but they want more data on it. So that's why, so that they can precisely model the ionospheric changes that happens. So therefore, this launch happened, and the next, actually, you know, those solar eclipse with similar characteristics is going to happen at around 2044, which is, I mean, the total solar eclipse will be around 2044. I'm not so sure whether the US will be able to see it or not. So we need to see whether, if it is so, then they might launch it. But if it is not, then the other scientific community who can witness the launch may see it. So amazing things. You have to, you know, in space, this happens. You have to align your projects with the alignment of the stars. Literally, that happens, right? Planets, stars. So the Voyager mission which launched, the 2 Voyager mission which was launched, they identified that the stars or the planets are aligning in such a way that they can use the gravity assist of the Jupiters and Saturns and all those things to their advantage, so that they can slingshot Voyager out of the solar system. So that happens once in a lifetime. In 100, 200 years, it won't happen. So you have to be very strict on the deadlines in that case. You can't have afford those scrubs or extension of the deadlines. So in space, the scrubs and extension of the deadlines is very common, but not for some missions.
Did you call STMPI?
I called PTM to see if he can replay us the data.
I'm setting it up now.
Excellent, thanks.
And we have the third and the final one ready on the pad to be launched right here in around T minus 37 minutes from now. And we'll see how it will look like. We have already seen two and it looks amazing always.
PTM.
Go ahead, PTM.
Should be playing back. Let me know if you see something.
Yes, we are seeing data. What time is this? Is it before launch or at launch?
It's about 40 seconds before launch.
Okay, we are getting data.
And MNO, do we have TMLOS?
Yes, sir. I called out TML LOS at 1936.
Copy. And did we stop recorders?
Yes, sir.
Copy. Okay, programmer, set us up for 2015 T0.
Roger, set up 2015.
Great. It's T minus 36 minutes from the launch of the third and the final Black Brant IX rocket. And it's been a great 2 launches. So back-to-back launches, and this is the third one which is going to launch. I'm really excited for this one also. So yep.
ROA, RSO.
Go ahead.
Vehicle performed nominally. Check item 519.
Joshua, they took the camera off because you can't see the rockets when the engine is not running when it is in the space, right? Then how in that case you need to make people see the control room only, right? They were tracking the rocket till the time the second stage was igniting. So there you have it. So nothing is fake, everything is. We have engineers and scientists have their brain for this very moment, so everything is working in conjunction for a proper scientific experiment. If you are just joining in, we have okay. Yeah. So guy.
So TD on 1.
Sorry, so go ahead.
Do you care for a quick discussion with SC on channel 5 about these 3 people?
I think that'd be a great idea. Let me change my headset better.
This is no waste, Steve. They are trying to see the effects of the solar eclipse on the ionosphere. It will benefit you only. Your communication devices, right? They should not go down when solar eclipse happens. It does not go down right now. But if you don't study and if you don't know the behavior, there might be some days it may go down because of some sort of issues. You don't want that, right? You want to use your phone during the eclipse. Specifically during the eclipse, right? So let them do their job and study all those things which they want to study. So yeah, this is the third and the final rocket waiting to be launched. 2 rockets have already been launched. and the data is looking good from them. So as I said, these rockets, they just go up and then come down, so they are not recovered or reused again. So they just burn up in the atmosphere, some of that, and the other part just they are aiming for the range to be in the ocean, so it just falls into the ocean, and nobody collects it. So there are two stages, the first and the second stage, both of them falls, and then finally the payloads also fall. They all fall in different ranges. So first stage falls first, second, and then the payload. So I mean, that's how it is. But yeah, two of them have done their job. It's very around 7 to 8 minutes only you get.
Welcome back, and thanks again for joining us
Okay.
for the broadcast of the APEP mission, 3 rocket salvo from here at Wallops Flight Facility. Camera is now zeroed in on our final launcher, the 50K launcher, which will be our final of the 3 rocket launch event today. We just passed 32 minutes and counting for the final rocket. We go over some 10 things to know about the ionosphere. I dug up from science.nasa.gov. In case you didn't know, the last total eclipse that we had visible here from North America was in 2017, and the next total solar eclipse that will be visible from North America will not happen until the year 2044. So we're going to have a while to wait for our next one. That's why our PI, Dr. Prajati, is very excited about the data set he's going to get collected from this event here at Wallops today and the launch of 3 rockets into the ionosphere. Some things about the ionosphere: it's a home to all the charged particles in the Earth's atmosphere. Earth's ionosphere overlaps the top of the atmosphere and the very beginning of space. So we're right on the edge of space as we enter into the ionosphere. The sun cooks gases there until they lose an electron or two, which creates a sea of electrically charged particles. The ionosphere is also where Earth's atmosphere meets space. It stretches roughly 50 to 400 miles above the Earth's surface, right at the edge of space. Along with the neutral upper atmosphere, the ionosphere forms the boundary between Earth's lower atmosphere, where we live and breathe, and the vacuum that is space.
MM check, 521.
We hear him checking through the countdown right now. At 521, and our total count for the 3 rockets today. Sometimes the ionosphere changes, and sometimes it's unpredictable. The ionosphere is constantly changing because it's formed when particles are ionized by the sun's energy, and the ionosphere changes from Earth's day side to night side. When the night falls, the ionosphere thins out as previously ionized particles relax and recombine back into neutral particles. That's why the eclipse is of interest to our PI, because this is all happening inside of a very short window where they can target the science with their vehicles and sub-payloads that are deployed. We just passed T-minus 30 minutes and counting for our final launch. So let's listen into range control.
That's affirmed. In work.
I'll just be back, guys. Give me a second. I'm not, I mean, the stream will keep running, so don't worry about it.
ROA, just checking. Did we already get RF avoidance?
You didn't need it the last time.
Copy.
Do you need RF avoidance for this one?
No, that's a negative. Do not need it.
Copy. TV off console for 5 minutes.
ROA LPM.
Go ahead.
Check items 523 and 524. Pad 2 is clear.
Copy that.
I'm an OSPM. Would you verify that radar is on and operational?
Confirm.
Copy. Check 525. TDs PM, we're a bit early, but I'd like to request your permission to move into terminal count.
I have no objections to that.
Is it so? We expecting another earthquake, huh?
PI, PTM.
Is it my superstition coming into picture again? After solar eclipse, some natural calamity happens. All right. So we are around T minus 25 minutes from the launch. The Black Brant rocket looks good. It's fine sitting over there. In 25 minutes from now, we shall see the final launch, which is after the totality. So the solar eclipse is done and dusted now. After the totality, they will be trying to understand how the ionosphere changes. So yeah. Okay guys, so if you did capture some of the videos of this, you can tag me on Twitter at @RocketGuy. We'll see it. But let me know if you are watching it, if you did see the solar eclipse also. Did you if you had those eclipse glasses, you were be able to see it, because I haven't seen a solar eclipse in my lifetime, because I never had access to any of those eclipse glasses. So but now I will see it once it happens over here. It's not visible over here, so I can't see it right now. But yeah, I will definitely see it once it happens here, and I'll try to get those Eclipse glasses. Or as they said in the video, right, you can see it using those pinhole cameras as well as those other things which you can get, right? But
okay, SRPO, PTM, giving a little update.
Go for PI.
All right, so yeah, on this one again, it looks like all the booms came out. I see where Adam says that one of the switches may not have latched up for the telescopic boom, but from our perspective, the signal looks very comparable between all the booms which did have micro switches. The up leg, the digital accelerometer and the analog accelerometer, they all still saw that periodic pulse. Not quite sure what that is, whether it is something banging around or if it's some leaking ACS gas or deadband, not quite sure. But after the apogee, that thing mostly went away. So the down leg was a lot cleaner. It was still there, but an order of magnitude smaller. Overall, the sub-payloads all look good. The D1 seemed to show very little coning, although D2 and D3 did have coning on them. So a lot more assessment to be done. But overall, yeah, all of the sub-payloads came out, and seems like all of the booms deployed. None of them got stuck. Some finer details to work out, but all in all, good.
awesome.
Happy to hear that. Thanks, PI.
You have the mission update of the second launch. It went as expected, although they are seeing those accelerometer readings. Some patterns are there. As I said, something might be banging around, but they have to see what is that. And that is basically the unwanted noise. They will filter out that noise from the data which they are receiving right now. So some additional work, but yeah, I'm glad they were able to at least see that this is not something which is expected, and hence you can just filter it out. It's not like in space because of eclipse something is happening. That is not the case, because accelerometer obviously you can't have accelerometer is such a reading in which you want basically you get that reading from some sort of physical thing moving around. So because of the eclipse, obviously you can't have some mass created and that moving around. So yeah, obviously that is some sort of noise only in the rocket of the various payloads that is there.
As we just heard from the PI himself, nominal data coming back. He seems very happy with the second vehicle. The first one was same. So we still have the third vehicle left to leave Wallops here today as part of the three-vehicle APEP mission. Our next T0 is targeted for 2050 GMT or 1615 local here. We're at about 18 and a half minutes and counting, barring any holds. As you know, on the second vehicle, we had a couple minute hold around 3 minutes, which pushed our T0 back. But looks like we're marching on now, and until someone sees something where they would like to call a hold, we may do that again around the 3 minute mark. We had the opportunity to interview our PI, Dr. Oro.
I don't get it why this happens. Wait for it.
Berjadia, I think you did that, right? My team member in here got to interview. He answered with the ionosphere is an upper layer of our atmosphere extending from about 100 kilometers to 1,000 kilometers, 60 to 600 miles roughly. And there the pressure is low enough that charged particles can remain free and show collective behavior. This layer reflects and refracts radio signals, and it also impacts satellite communications as the signals pass through. Thus, understanding it and being able to model its dynamics is crucial to making sure that our increasingly communication dependent and driven world has a smooth operation. So it's all good things we're looking for here today. The Eclipse gave us a targeted time and space to throw science and collect data rather than, as mentioned earlier, a 2 to 3 week campaign. in order to collect science, this eclipse gave us a 2 to 3 hour window where we could launch 3 vehicles and then sub payloads for a total of around 12 to 15 different data sets that they're going to take back and study to better prepare us to be able to model that ionosphere and prepare for perturbations in the future that may happen. Next, he was asked in just a few sentences explain what APEP stands for and briefly describe the overarching goal of the project. APEP is, of course, an acronym. It stands for Atmospheric Perturbations around the Eclipse Path. And as the eclipse shadow races through the atmosphere, the rapid and local sunset and sunrise create large-scale waves and small-scale perturbations that have the capability to interfere with radio communication. APEP's main goal is to study and characterize these perturbations. Again,
Nice.
We are currently 16 minutes and counting with no holds, with a targeted T0 for our third and final rocket today, our third and final vehicle in a 3-rocket salvo of 2050 GMT, or that's 1615 local. Did I say 2050? 2015 GMT, 1615 local time. We will launch our third and final rocket as part of the APEP mission.
Whoa.
As we see, we will be launching from the 50K launcher.
Hey, we have radars and all. Where this camera moving? We have cars. Hey, yeah. Okay, this one is a nice view. We can see. Oh, we have people are there to see the launch from very close, right? It's great. It's awesome. It's a very small rocket, so you can reduce that area from where you can watch the launch. So amazing. So guys, if you haven't if you're just joining in, let me tell you, 1, 2 rockets have been launched. This is the third and the final rocket, which is going to launch after the totality, which has already happened. So they want to study the
preliminary wind-weighted settings.
Okay, so they want to study the before, what happens before a totality, at the totality, and after the totality. So they have all the data sets. That's why they have launched 3 rockets. And this is the final one waiting to be launched. The people who have been there to see this rocket launch, they have witnessed 3 in succession. So lucky guys over there. Yeah, so, and this rocket is going to study the ionospheric changes because that is necessary to, we need to monitor, basically model the ionosphere as precisely as possible, because ionosphere is full of ions. It affects our satellite communications. So if we
copy, program will hold us at 10.
Roger, hold at 10.
Okay, I think we will be having some sort of hold.
In 25 seconds and counting. Right now, we're going to hold
APM,
it 10 minutes.
Recorders are started.
Currently, the range working, no issues. This will be our third and final vehicle from the 3-rocket salvo.
Launcher preliminary wind weighting settings are azimuth 101.0, elevation 79.0.
Copy that. Check 533.
And that's our final input to the azimuth and elevation for the launch rail that will send our third and final vehicle into the ionosphere here today from Wallops Flight Facility. We missed the range checks again. I've been trying to get them in the range, but I was talking too much, and I was just reminded we missed range checks again, which gives us a great opportunity to see into behind the scenes here, the folks that all have a say in how this goes. Of course, our test director runs the RCC in the room, along with range safety, the PM, our PI, and surveillance. But so many folks are polled before we go into a launch. I just want to read down some of those folks. Radar coordinator, RC, M&O, mission and operations lead, the programmer, the LWO, or launch weather officer. LC is the launch control you just heard take the final settings from the ROA. LPM is our launch pad manager, part of our ground ops, our range ground ops group that's out on the Wallops Island that prepares the pad and the launchers. They're in some of those buildings and shelters you see in the live feed out on the island. our surveillance control officer, or SCO, our range chief engineer, our main payload instruments, our payload control, NASROC payload telemetry, swarm TM, swarm payload control, our attitude control system, the NASROC mission manager, our PI, of course, SRPO. Then we end with the range with the project manager or PM, the RSO and range safety officer, and then finally our test director. All have to give a go according to information that's coming in with range activity, weather, range foulers, which we're currently experiencing none of. So we have boats, surface vessels, and aircraft that we keep clear of the area via our surveillance assets. So all of those folks and that team comprises what it takes to launch these vehicles from Wallops Flight Facility. And we've done 2 today. We're going to get our 3rd, which will be quite a milestone. I know in the past we've launched HREX with a 5 rocket salvo. I don't remember the year. I was in surveillance at the time. I don't remember the year, but we did launch 5 in 5 minutes back in 2000 teens. We're Googling right now. We're trying to figure it out.
Wow.
2012? Not quite to the teens. Okay. 2012, 5 rocket launch from right here at Wallops Flight Facility. Today, we get to experience 3 inside of a total eclipse here on the East Coast, only 81% totality. We're coming out of it now. If you're able to make it outside, we both stuck our head out and felt the change in the atmosphere. It got chilly. It got dark like it was going to rain. Yeah, the birds were chirping. It was very serene here on the eastern seaboard. It's a beautiful sight, and but it was a bit... it was different, definitely a change, drop in temperature and sunlight. And we had our safe glasses on so we could observe the eclipse at 81% totality. So we'll stand by now as we're approaching. Here we're going to lock on 10 minutes, I think, and counting. And boom, we're there. We're 10 minutes and counting. Now for our 3rd and final launch, we'll listen in and wait for the PI to give us his go when to pick up the count. And we'll get a new targeted T0 for you in just minutes.
Awesome. 5 of the launches they launched in 2012. 2012, sorry.
TD is a PM.
Go for TD.
2012.
We're looking at a new T0 of approximately 1620, adding 5 minutes, and we'll update that as time moves on.
All right, 1620.
Copies.
I will change it. All right, T minus 14 minutes from the launch. We had a few hold at T10, but now I think we are T minus 14 minutes from the launch. I am 5 miles from the launch pad and would have loved to share some videos. You can do that, Ivan. You can do that. You can tag me on Twitter. Link is down in the description at @RocketGyan. And that's what we do. Once the launch happens, we go to the Twitter and see if people have recorded something. If you have recorded something, you can tag me on Twitter and we will see it live over here. So about this launch, if you don't know, guys, this launch is the 2 of the 3 have been already done. So 2 launches are done and dusted. They have collected the data, and this is not the first time they are doing this. So back in 2017 also they launched 3 of these rockets to get some data during the solar eclipse of the ionosphere. And as I was saying, the ionosphere is very necessary because you need to model it properly. It's very, as I said, it's very long. It's 60 to 600 miles. That is the the range of the ionosphere, and you need to model it properly so that you can have satellite communications and other things designed in that way, because ionosphere is filled with charged particles. You don't want to mess around with charged particles because charged particles deflect your waves, the communications and all. Also, you don't want humans to be in a place where there is accumulation of charged particles. So you need to better understand all those ionospheres and everything. So so that there is certain portions around the earth where the charge density is very high. So when you are going outside of the low earth atmosphere, low earth orbit, sorry, low earth atmosphere, low earth orbit with the humans on board, you need to avoid those places. During the Apollo era also, they had to design their trajectory in such a way so that they avoid those red hot zones, right? So that's why the study of the ionosphere is very necessary and important. They already got the data before the totality, during the totality, and now they are aiming for the after the totality. We are T-minus 11 minutes for that, and we'll see whether this last of the launch is successful or not.
TD programmer.
Go for TD.
We're not going to be picking up at 2020, is that correct?
TD's PM, yes, we intend to pick up.
Want to pick it up at 2010?
No, Roger. I was looking at the wrong display.
Oh. All right.
This is SRPO to TD. We do want to go ahead and pick it up on the next even.
Roger, next even. We'll be picking it up at 2011 Zula.
So Zulu time is, I think, the UTC. No.
So as we just heard, we're preparing to pick up the count in about 25 seconds at 4:11 p.m. Eastern time. That would set us up for a 4:21 T0 Eastern time from our 50K launcher, the third and final rocket in the APEP mission here from Wallops Flight Facility. As we prepare to enter the terminal count at 10 minutes, let's listen in to the range control.
Please start recorders again.
Yep. So Zulu time is the UTC time. So UTC or the GMT, whatever you want to say.
Recorders are running.
The reference line, right?
Thank you, sir. Check 531.
Of all the time zones around the world. Greenwich Meridian time. I don't know the story about it though. Why that became the reference point.
ACS check 538, 539.
T-minus 8 minutes from the launch. The Black Brant rocket is sitting quietly over there and nicely over there. And the weather you can see is amazing. And guys, if you haven't subscribed till now, please do it, because tomorrow we have another amazing launch. The last Delta for Heavy, the heavy metal boy launching. So I'll be streaming that also. So please ensure you are subscribed to this channel so that you can see the last Delta 4 Heavy launch when it is going to launch. Started as a everywhere on the planet.
PM, we will be holding it T-minus 3 minutes for no more than 5.
Again, a hold. And talking about these holds, right? So these holds are not technical. I mean, it's not because of the rocket. Rocket has some issues or something like that. It's more dependent and more inclined towards the scientific objectives. So they want the you know, the area in which this rocket will be launching to. We have 5 minutes hold.
Beacon is trackable. Good 5 code. Good lock.
Thank you, sir. Check 543.
Hey Nathan, welcome to the technician membership. Thank you so much for becoming a member.
Check through the go no go criteria for the launch countdown. We passed 7 minutes 30 seconds and counting with an expected hold at T-minus 3 minutes from SRPO and the PI. Something the PI would like to see, probably science-wise. We're experiencing no weather or range Fowler phenomena currently, so we're good to go for launch. Just going to get to a spot where Dr. Aro Rajadia, our PI, is happy with the science, and we will launch our third and final rocket today as part of NASA's Atmospheric Perturbations around the Eclipse Path, or APEP, mission from Wallops Flight Facility here in Virginia.
Check 546.
Again,
awesome.
At 3 minutes, we will hold for no longer than 5. So let's listen in, and we'll target a new T0.
Let me change the T0 only, no longer than 5. So I think they'll be aiming for the last of the T0.
DPM to Simnio. MNO, I can give you readout has a lock on swarms 1 through 4. 6 TM lock on 1 through 3.
Yeah. All right. So thank you so much, Nathan, for becoming a technician member. Really appreciated all the members of this channel and the Patreons. I really want to thank you. Because of you guys only, I'm able to stream and give you all the knowledge that you want. And we have a great time together. So thank you so much for all of that. And if you want to support me, guys, you can become a member as Nathan, and you will be having some other perks also, so look out for that. Thank you so much again, Nathan. Really appreciate it, bro. So Zulu is mostly for the military thing. Nice. I did not know about it.
Final wind weighting settings are as follows. 101.2, elevation 79.2.
Azimuth 101.2, elevation 79.2.
Good readback.
Great.
LC, ROA.
Go for LC.
50K launcher, final wind weighted settings are azimuth 101.2, elevation 79.2.
LC copies and work.
You know what these wind weighted settings and all those things, what all are these? So basically the arm which you are seeing, right, that
50K launcher final wind weighting settings are
okay.
One.
So yeah, I mean these settings are for that arm which is taking that rocket on the pad, which is holding on the rocket on the pad, right? That stand or something, whatever you want to say that. So those are the settings for that. They have to aim. It's like, what should I say? Kind of a gun which you hold at an angle so that you reach the point where you want to reach. And obviously that point where you want to reach in case of rockets is affected by the wind. That's why those wind weighted settings and all those things come into picture. And you have that, what should I say, that thing taken into account before launching. There's that. Just waiting for what has happened here. A strong back I mean they have their different terminologies for all these things. Strong back is mostly there for Rocket Lab and SpaceX. Every other rocket company have their own way of conventions, right? So it's a trust structure, yes, you can say that, because that's a more of a generic term. But yeah, so they have to aim it in such a way that, because the rockets engine is nothing but an SRB. They don't have a gimbal, they don't have anything, so they have to aim it in from the gun itself. Launches like a gun only. They don't have any active gimbal control in the rocket, so they have to aim in that way so that all the wind and other things, perturbations caused by other things, are neglected and negated, not neglected, negated, and we have a good targeted launch. So that's why. So this is we all right. The hold is because of the scientific what should I say, environment. I mean, the scientists over there, they want their environment to be ready for the when the experiments are done. So right now they're monitoring all those things right now, like the space weather and all those things, right? So that they can have a optimal environment in which they can get the maximum readings. So that's why right now there is a hold, but there is no as such hold. They can hold it for around T+5 minutes only. So that's why I've adjusted the timer accordingly, and hopefully they should pick it up very soon. We'll see that. You are actually right about that.
How long could we hold here with our current balloon?
Stand by.
I'm not American fun time, but I do like rockets, and I do like to share it with the world. So that's why I'm here.
Maybe another 5 minutes, but if we're going to go much past that, we're going to have to do another balloon. That's going to take time to actually get that balloon up there, going, cut settings, and get you new settings. So it's hold another 5 minutes, and then it's going to take some extra time.
Copy that, RSO. Thank you.
Okay, another 5 minutes.
Is that 5 minutes from right now, or 5 minutes from what the plan we have right now?
That's 5 minutes from right now.
Copy.
5 minutes from right now. What does that mean? Updated the timer. Yeah, so BC Stargazer says ask it what is clockwise, and they won't know what you are talking about, but if you say the buffering sign, they know. Digital age, digital people, right? In our times, during our times, analog clocks and all those things were there, so they knew how to read those clocks, right? Nowadays we don't have that. We all have digital timings.
Sorry, go ahead.
We're looking at picking up the count at 1625 local, which would put us at a T0 of 1628. Will your balloon still be good by then?
Stand by.
All right, 1628.
So we're okay with that as the absolute maximum, but obviously you're incurring extra risk of us going out in variability. So, but anything after that, we're definitely going to have to get up another balloon.
Okay. So 1628 is the new launch time.
Copy, RSO. TD, we're going to target 1628 for our T0. You copy?
Copy. You copy, programmer?
Programmer copies. Targeted T0 2028 Zulu.
All right, so we just heard a new T0 1628 now targeting. You heard a little chatter there between the PM and the RSO and the TD asking about balloons. We do launch weather balloons here that give us wind-weighted settings for our launchers. So The balloons are launched from Wallops Flight Facility, mainland and island, and we get at altitude wind, velocity, and direction. So the range safety officer and their team will evaluate the wind weighting settings, the data from the balloons, in order to give us good settings for the launcher settings for the rail. So that's what you heard. RSO, he didn't want too old of data. We like to keep our data fresh on what the winds are at elevation, so we know that we are providing safety to the public out there when we launch these vehicles from the launcher. So that's what you heard there in that little interchange there between RSO, PM, and TD in our efforts to get the science window the PI wants and remaining within safe parameters for launch. So we are now, we're still at 3 minutes in holding. When we pick it up, we're looking at a 1628 or 2028 GMT launch, which would be just over 4 minutes from now.
4 minutes from now. They are launching weather balloons, so they might be getting ready to launch a weather balloon, but what the conversation meant was, let's say if they move ahead ahead of 1628, they will have to launch it compulsory. So if they are aiming for 1628, most probably they won't be needing that another weather balloons. But yes, weather balloons, all those high altitude balloons are necessary for us to get the idea of high altitude weather. It's a very good way and instantaneous way, and
All
gets
stations this net, all stations this net. Stand by to pick up the count in less than 30 seconds.
yeah.
All right, as we heard from PM, we're about to pick up the count in 15 seconds. We will be 3 minutes from counting. Lots of range chatter going on the net. So we will stand by. We've got a great picturesque view there off of our front porch in the Atlantic Ocean and our 50K launcher for our third and final launch as part of the APEP mission.
DLC check 556. DLC check 557.
ACS check 558.
M&O DPM.
DPM, this is the M&O. I can give you a good TM lock and verify no changes on TM signal strength.
Copy that. Check 559561. RC DPM.
RC go.
Confirm no change in transponder.
Confirm, no change.
Check 560.
So we are T-minus 2 minutes from the launch. Everything is looking good now. I am hoping they won't be doing another another hold. That's because that hold window has passed now. Another hold means another
launcher settings are as
whether a balloon has to be launched. But I think we are good. Under T-minus 2 minutes. This is the final rocket which is going up in the space for the solar eclipse launch. So let's enjoy this one, and hopefully this will be one of the final rides, and we get to see another rocket getting launched. As usual, this, if you are just joining in, this is the view map. You can see those area wherever you live from this map, and accordingly look at the place where you can see the launch. So let's see. T-minus 1 minute 14 seconds remaining.
Yes. Go. PI. Go. SRPO.
Go.
Check
1 minute.
568, 569.
SPLC check 571. Go.
Okay, we have 50 seconds remaining. It's going quick, right? Just don't blink your eyes, guys. You will miss it out for sure. Just don't blink. Minus 40 seconds remaining. Everything is looking good. Finally, it's happening, guys. We waited for such a long time. Minus 30 seconds remaining.
Verified. Check item 575.
T minus 20, 19, 18, 17, 16,
check 577,
14, 13,
12, 11, 10,
9, 8, 7, 6, 5, 4, 3, 2, 1. Mark T0.
T0, and we have ignition and liftoff.
Radars are tracking.
Plus 10.
There you go. The first stage has separated. Second stage has ignited. You will see in the animations also.
2 and 3 on the booster.
We'll see. There you go. I did not have the perfect, mission profile, so that's why there might be some here and there.
Plus 30.
But yeah, you can see everything is looking great. This is the last rocket which has been launched.
Plus 40.
And we are approaching burnout. And we have burnout. Now the payload separation will be coming up very soon. Hey, look at those.
Squib,
1 minute.
sub squib and break wire.
The payload separation is going on now.
ACS 1 on.
Door squib and all plunger switches. Eject
one
squib.
on.
all
Payload
break
separation
wires.
has been done. Swarm separation
Squib and break wires.
is completed.
Splash on the booster.
The booster is first stage has there was a splashdown for first stage.
STM has lock on all swarms. All are transmitting at high power.
All 4 swarms are looking great.
All radars on payload.
Everything is working as per the plan. Final launch
Boom, deploy
successful.
squib.
ACS 2 align.
All pots.
And as we hear the chatter quiet down, we heard we had splash on the first stage. We also had good tracking on the radars. The PI seems happy now. They're at the bottom center screen. You see the PM behind him, test director up on the pedestal. Everyone now intently looking at data screens directly in front of them on our video wall in the range control center. And they will collect the data now, head back to the laboratory to make sure they get everything happy. I want to thank you for joining us today for the coverage of our NASA's APEP mission, an acronym for Atmospheric Perturbations around the Eclipse Path. I just had to say that word one more time, perturbations. I practiced all week on that. So we launched 3 rockets today as part of a salvo on all 3 of our launchers from the pad on Wallops Island. Pretty exciting day. I hope you enjoyed the eclipse. We'll leave you with a What's Up at Wallops video here, and we'll see you again. Look, make sure you tune in to our social media pages for updates on everything going on at Wallops. Good day.
Baumgartner maneuver with the Baumgartner maneuver. How cool was that? That was something. I did not expect that first rocket wala thing. So that was something. Great. We'll go to Twitter to see if someone has posted something. Okay. Nothing here. So people have they nope, nothing. Nobody has posted anything. Three rockets back to back. How cool is that? This was amazing. Thank you for tuning in, Candy Curry. Is it? I think so. I read it right. So tomorrow also we have a amazing launch, which is the Delta IV Heavy. That to a last launch of that. I will try to stream that, so do join me for that too. And we also have an Angara test flight from Vostochny Cosmodrome. The first test launch of the Angara A5 launch vehicle. Not so sure whether we'll have the... Oh, we do have the feed for that. I think I should be able to stream that. Let me check that. I think I shall be able to stream it. We'll see. So Angara test flight. That would be amazing from Russia. And after that we have a Delta IV Heavy launch scheduled. So there's that. So yeah, couple of cool launches in queue. Thank you so much for tuning in, guys. If you want to support me, you can do that by becoming a member or a Patreon. And super chats are always enabled for one-time funding. But yes, so we'll join again for tomorrow for Angara test flight and Delta IV Heavy. Thank you so much for tuning in. I hope you liked the stream and I hope you learned something new. If you want to have a good amount of knowledge about this launch, you can do that. You can have that by rewinding it a bit, replaying this live stream, because I have discussed a lot about what this mission was all about. So in the first section of this of our stream, that is known as a pre-launch sneak peek. That's what I have come up with. If you have better suggestions, you can always give that. But yep, I must watch the movie. Which movie? Yeah, so I think that should wrap up for today's, should be a wrap up for today's launch. So I hope you liked the stream. You did. If you did, give it a thumbs up. And I hope you had a great fun with the launches as well as with the Eclipse. And we will meet again tomorrow for the Delta IV Heavy and the Angara launch. Until then, this is Priyanshu Rohila. You just saw Rocket Gyan. Stay safe, stay healthy, and bye-bye.